Uh, so thank you for joining us this week. For today's Tech Talk, we're going to be going over gRPC. So my name is Ray. I'm the lead software architect here at Modzy, and this is gRPC. So we'll start, like we often do, by previewing the next set of talks. So several of them have yet to be announced, but next week, Seth and Samo will be going over running models on the edge. So some of that does actually build on what we'll discuss here today. So we're excited to have you guys here today and to join us next week. All right, so what is an API, right? At its core, an API is a contract, right? A set of rules that dictates how data is exchanged between systems. And an API allows applications to communicate with one another. And this is fundamental to how the web works today, right? So we can invoke remote systems to transform data, retrieve data, and aggregate data to create something entirely novel and on its own. And oftentimes the API are the products themselves, right? So think of Twilio, Airbnb, AccuWeather. All of those companies charge a premium for access to their APIs. Now, APIs come in all sorts. You can think of SOAP and XML. GraphQL is another popular one, but by far the one that we have most experience with is RESTful. So this is JSON over HTTP, and this is just an industry standard of a type of an API, right? And RESTful's super popular, right? And it's easy to see why. JSON is something that is incredibly simple for both humans and computers to understand. So just by looking at the snippet on the left here, and it's very clear that this is a record of a person, and the attributes associated with that person are also pretty clear to see. So REST utilizes a set list of HTTP verbs that each align to some standard action, right? So create is post, updating is put, retrieving data is get, and so forth. And we make these requests to these HTTP endpoints, right? So an example of an HTTP endpoint is here below, and this is pretty common, right? So you have your base URL, and you have a resource that you want to operate on. In this case, we want to retrieve, this is a GET request, so we want to retrieve a user. So we've got the user resource, and then we have the unique identifier for that resource. But then there's a nested resource beneath the user, right? So they have a post, or they have posts. So we want to retrieve a particular post made from that user. But further still, the posts have a nested object, right? So there are comments associated with the post. So we're retrieving the comments. And this is pretty common, and this is a pretty contrived example. But it illustrates a point, right? So HTTP endpoints can get pretty long. If this were an update, we'd be, chaining on an identifier for a comment at the end of this, right? We have query params, so on and so forth. So REST APIs maybe aren't so easy to implement effectively, right? So building a robust REST API is difficult. You need to think of myriad things. You need to think of the format of your endpoints, right? You can't box yourself off into a corner, and then that limits your extensibility of your API in the future. You need to think of security, efficiency, right? Am I going to send one massive object back, or am I going to expect a bunch of smaller calls to retrieve the same information? Auditability, security. Things like streaming is pretty difficult to do. And so, again, these aren't new problems, but they're problems that require some careful thought and consideration when developing an API. So Nathan, our head of engineering at Modzy, actually wrote a pretty insightful article about how we think about these issues and how we develop APIs at Modzy. So I highly recommend that we go out and read this article. A lot of really good points. Now, as developers, despite these problems, we interact with REST APIs on a daily basis. And companies know this, right? We're not sitting at a browser just making requests, and we're not sitting in front of a REST client making requests. We're actually integrating these APIs into our own code base, into our own application. And again, companies know this, right? So they offer SDKs or HTTP client libraries that kind of obfuscate a lot of the complexities of, building an HTTP server, the client, the headers, the security, so on and so forth. And they expose it all in something super easy to use, which we refer to as an SDK or a client library. So at Modzy, we support 4 SDKs. We support one in Java, one in Go, one in Python, and one in JavaScript. But there is an overhead to providing these client libraries, right? there's a human cost, and there's a time cost, right? So from a human perspective, right, we need to find developers that are proficient enough in a particular language, the language that we want to offer the SDK in, but also familiar enough with your product so that they can develop a very useful SDK, right? And then there's a time cost too. We need to maintain these SDKs. What happens as your REST API evolves, right? You have to go and you have to update each individual SDK. What if we want to provide a client library for additional languages, right? So what if we wanted to start offering SDKs in PHP, Ruby, C#, C++, right? The problem kind of magnifies. And now you've got double the time cost, right? Maybe even double the human resource cost. So is there something better, right? Is there a way that I can just give someone an API contract and say, here's all the information that you need to integrate within your product, what we offer? So the answer is yes, right? And that's where gRPC comes in. So gRPC stands for gRPC Remote Procedure Calls. It's an open source framework by Google for RPCs. I think it was open sourced in 2015, and it's part of the CNCF. So gRPC is built on top of HTTP2, and it utilizes protocol buffers for serializing the data. So what does this mean? This means that it's far less CPU intensive and much more performant over the wire. So when you have services that require on really low latencies, like perhaps a model on the edge or a limited device, then you're really going to get some high performances from something like gRPC. Something else that gRPC allows us to do is to generate clients in any number of supported languages. I think there are 10 now, but that means I can implement my server in my language of choice, so Java, for example. And by providing the API contract, clients can just generate their codes and start implementing right away without the need for us to maintain or provide any sort of HTTP client library. So it does this by using protocol buffers, right? So what's a protocol buffer? So it's just a mechanism by which we serialize some of the structured data. So again, this is also by Google, and gRPC uses this by default. It doesn't have to. So it does support things like JSON over the wire. But by and large, and you'll find mostly in the ecosystem, protobufs and protocol buffers are the main thing. So they are language and platform agnostic, and they are highly extensible. So we are only going to scratch the surface of what we can do with these protocol buffers. There's really just a vast amount of stuff that we can do. And so this works by using a user-defined, what's called a proto file, or a file that ends in .proto. In this proto file, you define your messages, right? So the data that's going through your requests, and your RPCs themselves, right? Your service calls. So in this example, we have 3 messages, right? We have a message of person. This has 2 fields of type string, first name, last name. We have a message called greet request. So this is a person, contains a person field of type person. And we have a greet response, which has a string field named response. And then we have a single RPC defined, right? So here we see this RPC is called greet. It expects a greet request as defined above, and it returns a greet response. So immediately as a developer, by looking at this file, I know exactly what data I can expect, but also what data is expected of me to provide to the server, right? And these protofiles are hugely important. These become your API contract. So this is what you will be disseminating out to the developers out in the broader space to interact with your system. So you have to be very careful and pay very close attention to how you define your protofile, because again, this is what you're sharing out to the world, and this is how the world's going to start interacting with your system. So with a fully defined protofile, we use what's called the Proto-C compiler. So again, provided by Google. In the Proto-C compiler, you pass it some information, the location of your protofile, the language that you want it to generate code in, and it'll generate these protocol buffers and these what are called client stubs in your server code for you. And so that's what makes us super powerful. If I'm working with a JavaScript developer and I'm implementing the server in Java, I can give them this protofile, and the developer has everything that they need through the Proto-C compiler to start integrating with my server immediately with no need of any sort of additional information. So what's an RPC? A remote procedure call is just an invocation of a service on a remote server, but it looks like you're invoking it locally. So that's not the clearest definition, and it'll make a lot more sense when we actually see an example of this, when we start implementing an example client. So gRPC supports 4 types of RPCs. Unary is by far the most popular. It's what we're most familiar with. The client sends a single request, and it receives a single response. Client-side streaming, so the client sends multiple messages, and the server responds with one message. Typically, it responds at the end of the stream, but not necessarily, right? It's up to the server implementer to decide when the server is going to respond to the stream. We have server-side streaming, so the opposite, right? The client will send one message and the server will send multiple. And then bidirectional streaming, or BiDi. So this is where the client and the server independently send multiple messages to one another. So they are individual discrete streams. So it's up to how you want to implement your server and your client to determine when within the stream you actually want to send some data back. And as a bonus, I really want to shout out this particular tool service project called the gRPC Gateway. So gRPC generation sounds great, but it's only limited to a few languages, right? So I know, for example, Rust is currently excluded from that list. We don't want to isolate those developers, right? Because if you don't give developers an easy way to integrate with your system, then more likely than not, they're going to choose not to, and they're going to look for an alternative or an easier solution that fits their needs. So with the gRPC Gateway, what this actually does is it creates a REST proxy in front of your RPCs. So you can continue to develop your services in gRPC. You can use gRPC for your internal communications or however you see fit. And exposed out in the same port, same server, you actually have a REST server as well. So with a few annotations in your proto file, you can, like your gRPC becomes a fully exposed REST API as well as a gRPC API. So that's it for the demo. I know I flew through those slides because I want to get to some live coding. I think it'll make a lot more sense if we see some of this stuff in action. But if you have any questions, please just reach out to the general channel. We'll hang out there for a little bit, and I'll be more than happy to answer those as well. So in the interest of time, I've actually pre-written this particular proto file. So this is just what we saw earlier today, right? So here I've commented some stuff out for the future, and we'll go as far as time allows. But I've defined 2 messages here, right? I've defined a hello response with a string field, response string, and a hello request with a string field called name. Here in my service, my hello Modzy service, I've defined an RPC, hello Modzy, which takes in a hello request, and it returns a hello response. So using this, we can actually generate all of the code that we need. So with this proto-c command, proto-c, I'm actually telling proto-c, the proto-c compiler, where this particular file lives, how I want it to generate the code, where I want it to put the code, and the language that I want. In this case, we're going to be using Go. So I ran this, and coming up here, we actually see 2 new files get populated. We have hellomodzy.pb.go and hellomodzy.grpc.pb.go. And so this is all the code that we need to start integrating with this particular service. So on the server side, we implement the server implementation. You'll notice that if we were to find hello Modzy, this is an interface, right? So we need to implement this interface on the server side in order for a client to interact with it. So we'll do that. So again, this is all of the boilerplate that you need from here to here to run a running gRPC server. Now, so for brevity, I'm not handling errors where I don't have to, so I highly don't recommend that. But we define a listener, so we're listening on TCP on port 50,051, excuse me. We define a new server. We register that server with a struct that we've defined above, utilizing this Modzy PB. So this is our hello Modzy proto generated code. And then we listen on the listener, which is port 5051. So going back here, we have hello Modzy. So let's go ahead and implement that. So a function that belongs to the server called hello Modzy. So this takes in 2 parameters. It takes in a context. Let's import that. And it takes in the request itself, right? And so that is of type hello request. Again, as defined by the proto file that we saw earlier. And this returns a hello, excuse me, Modzy.hello response and an error. All right. So if all goes well, we'll return something. So what are we getting? So, well, we're getting a name. So let's greet the name. So we'll create a string, call it greeting, and say hello. And then we'll concatenate the name from the request. So we'll just pull out the name, right? And this works because, again, in this message, we've defined a field called name. And through the proto-C, we know that the request is going to have this name field. So we can just pull that in. I'll add some excitement. So what are we going to return? Well, we're going to return pointer to hello Modzy. Excuse me, this is Modzy PB dot hello response. The response has a string called response string, and we'll return the greeting. And when we get there, we won't return an error. So we've already implemented the unary call on the server side. So what's it look like on the client side? So again, some boilerplate. We are dialing, so we are creating a connection to the gRPC server, and then we're specifying that we're not using TLS, so no TLS there. We'll handle this error, and we have this defer connection close, so at the end of the method, it'll close that connection. So we can create a function, call it unary, client, and this takes a Modzy service client. And so we'll just call, so again, it looks like we're invoking a gRPC call locally, when really it would be a remote server. In this case, it is local, but the syntax would remain the same no matter where the server is hosted. We're calling hello Modzy. Takes in a context, so we'll pass in a background context. And then it returns we need to create our hello request object, right? So our request is equal to our Modzy protobuf defined information. We'll create a hello request, and that takes in a name. So let's go ahead and type Modzy, that's our name. And then here, we'll pass in our request. Now hello Modzy, as we saw, returns the response and the error. So for now, we'll ignore the error, but we'll grab the response. Log.print the response string, again defined in the proto file. So we run over to our server, we can run this. Our server is running. So in our client, we've only created this function. So what we'll do is we'll call the function. That would be client equal to, let's see, it's not the client, this would be the connection. So it's always fun to live code. Let's see, what have we missing? Connection. Becomes So we're having some errors here, but thankfully some of the web technologies have actually caught up. And so with Postman, we can actually import, our proto file definition. So we've got our file. This is our tech talk, let's say 1.2. We'll import the definition. And we can, let's see, tech talk. Tech talk 2. 2, version 1. Okay, and we can actually invoke this particular service. So we can actually generate an example message. So it takes the proto file definition that we've uploaded, and it knows that the request field has a name. We are invoking hello Modzy. It expects the hello request. It takes in a name, this name, let's say Modzy, and we actually invoke the gRPC, and we have back hello Modzy. So our server definition is working here. And so this is huge because oftentimes one of the biggest issues that we saw in gRPC development is that it's really difficult to test your gRPC, right? You can't just make the calls on a browser because the browser runs on HTTP. gRPC is focused on HTTP2. And so now that we have tools like this, we're kind of lowering that barrier of entry to Modzy. So doing it on the code side here, what we'll do is we'll create a client. This is what we were missing. So this is equal to .new client, and we'll pass in the connection. So now we can call our unary with our client. There. And running this, hello Modzy. So we've got the same thing. So then we can get even more creative, right? So if we want an RPC server-side streaming here, right? So we can define another one, hello Modzy many, which takes in a hello request, so the exact same request. And then we have it returns a stream. So this keyword here, stream, indicates that it is a streaming response or a streaming request. So we're going to return multiple hello response messages. So with any change to the proto file, we'll have to regenerate the code. All right, so we just did that. So hello Modzy many. So back to our server code. We'll go ahead and create a new function here. So again, we are implementing the interface. And so streamings are a little different here, right? So we're not just taking in the context in the request because we are returning a stream. So we take in a request, and that is of type ModzyPB hello request, but we also have a stream, all right? And so this is the streaming object that we're going to start writing to. This particular stream object is native to the server, right? So we're not dealing with client-side streaming. So what we actually do is this is of type ModzyPB dot hello Modzy many server, and this just returns an error. So when we return, that is an indication to the client that the stream is complete. So what we'll do is we'll respond, let's say 10 times. Oops. For 10 times, we will create our response, and that's equal to our ModzyPB dot hello response. Our response string will be hello. Actually, let's do this. Create a new greeting. Hello. We can still grab the value from the request. This is greeting. Hi. Hello, request plot name. This is greeting. Hi. And then our response string here will be greeting. This is greeting plus. We have to convert the integer to a string. So we have this response. Now this is what we're going to send back, right? And we're going to send multiple of these. We're actually going to send 10, right? So what we can do is to the stream, we can send our response. And that's it. Then we will return nil. And for the sake of brevity, we can actually utilize, actually that might not be super brief. So in our client, create a function. We'll call it server stream. And client mtpd.modzy client. Hello, microservice client. And so, similar to before, we'll create a new request. And so how does this change, right? How does it change from going from a unary request to a server stream? Well, we will invoke client.helloModzyMany, and this particular call will take in a context, so context.background, and it takes in our request. And it returns, takes in our pointer to our request. And this will return a Modzy client and an error. So what we'll do here is a response stream and an error. So we can actually ignore the error here. Okay. Now we're going to get many messages in the stream, right? So what we can do is iterate through and response error from the stream that we get back from the server dot receive. So by invoking dot receive, we are receiving a discrete object from the stream itself. So if the error is end of file, then we know that the server's done. And then we can, if not, right? So if it's end of file, then we know that the server is complete. And then we'll break out of the loop. Otherwise, we can log.print the response string. So we'll go ahead and rerun our server. And here we'll call server stream. And we see back that we've received a stream of messages from the server here. So we are at time, but hopefully this gives you an idea of how powerful, a gRPC API can be by just using a simple proto file. And again, these are highly extensible. You can do many, many, many things with them. So I highly encourage everyone checking it out.